Welcome back to all our viewers. Maths Marathon, Abhiram's Maths Marathon classes. In this session, I'll be discussing the PYQs of JEE Main going back to 2019 limits topic. PYQs, January and April shift. Both I'll be covering all the questions asked in 2019 JEE Main. The topic is limits. In the previous session or the previous video, I have done concepts and formulas I explained on limits. The synopsis part of limits was explained along with examples. And for our new viewers, I am also a new YouTuber and I have a lot of experience in teaching mathematics exclusively for PU students, and I'll be uploading many videos in the coming days. Not only JEE Main, also various competitive exams. It might be KCET, it might be NDA, or it may be VIT, AAA, MAHE, BIDSAT, many competitive exams. Our aim is to crack all the PYQs of various competitive exams. Today in this session, I'll be doing limits 2019. I'm starting in 2019 now. 2019, 20, 21, 22, 23, 24, 25. One by one we'll be covering topic wise. All the PYQs will be covered. Okay. And also I'll be explaining all the PYQs in detail. Today it's limits, PYQs, both January and April shift. Totally, there were 13 questions asked altogether from January shift and April shift. I think in January shift there are 7 questions and in April shift 6 questions. Totally 13 questions were asked. I'm going back to 2019, just before the COVID we had. 2019 because 2019 onwards the NTA has been conducting the exams, JEE Main exams, National Testing Agency. Okay, so from 2019 onwards they started to conduct the online exams. Different shifts were there, okay, from January shift and April shift. In January also they had many shifts because 2019 onwards they're conducting online exams. JEE exams are conducted online, okay, so computer based test I can call CBT. So many shifts are there. January 6, first shift, second shift, like that. Those who are new to JEE, not aware of JEE, for them I'm telling you there will be 2 phases or 2 shifts. One in the month of January, another in the month of April normally. But during the COVID period 2021 and 22, they conducted many exams, not only 2 shifts, they conducted 4 shifts I guess in 2021 particularly. We had a devastating COVID wave in 2021, correct? So all are aware about those things. During that time or in that year they are conducted the JEE exams in 4 shifts, February, March I remember, and June as well as July I think so. We'll see, okay, all those things. 4 shifts were conducted, I mean 4 sessions were there, and you'll get different dates. January 6 first shift, January 6 second shift, like that. Date wise you'll have you'll get the allotment, okay, to write the exams. And morning shift will be from morning 9 to 12, and afternoon shift on the second shift we call it will be from 3 p.m. to 6 p.m. like that. So it depends, okay, whichever shift you get you have to write that exam. So one by one we'll start with 2019 JEE Main limits, January and April shift. The first question. Limit y tends to 0, square root of 1 plus root of 1 plus y power 4 minus root 2. Whole thing is divided by y power 4. Question asked on 9th January, first shift, 2019. Okay, so various options are given here. Limit y tends to 0 is given. If you apply the limit directly, definitely it takes 0 by 0 form. Already I discussed various indeterminate forms and also the various methods of evaluating limit. Our main aim is to remove the indeterminate form. Whenever a limit problem is given to you, our main aim is to remove the indeterminate form. There are 7 indeterminate forms I told, correct? This takes 0 by 0 form. If you apply the limit directly, put y equal to 0 here. 0 power 4 is 0. 0 plus 1 is 1. Root 1 is 1 plus 1 to root 2, correct? Root 2 minus root 2, 0 by 0, 0 power 4 is 0. It takes 0 by 0 form, correct? It takes 0 by 0 form, hence we apply L'Hopital's rule normally, correct? But here in this case we don't apply L'Hopital's rule because y power 4 is there, right? It takes more time if you apply L'Hopital's rule. At one stage you may not get the answer. For CET level questions, you can apply L'Hopital's rule. One step you'll get the answer. But this is JEE level question, correct? So question asked in JEE, correct? So you may not get the answer so quickly if you apply L'Hopital's rule. So I'll avoid using L'Hopital's rule for this problem. Instead of applying L'Hopital's rule, I shall apply method of rationalization. You see, root of 1 plus root of 1 plus y power 4 minus root 2, correct? Divided by y power 4. It takes 0 by 0 form. Given limit is taking 0 by 0 form. Whenever you get 0 by 0 form, normally we apply L'Hopital's rule, but I don't apply L'Hopital's rule here because you won't get the answer so easily if you apply L'Hopital's rule. You have to apply the L'Hopital's rule repeatedly, twice or thrice or many more times to remove the indeterminate form. So what I'm going to do is I'm going to rationalize the numerator. So what I'm going to do is limit y tends to 0, limit y tends to 0, whatever is given, I'll write same thing, root of 1 plus root of 1 plus y power 4, correct, minus root 2 divided by y power 4 is there, correct, multiply and divide by root of 1 plus root of 1 plus y power 4 plus root 2 divided by same thing, root of 1 plus root of 1 plus y power 4 plus root 2. Okay, numerator, I'll apply the formula a minus b into a plus b, the basic algebraic identity you know, correct? A minus b into a plus b is a square minus b square, right? So applying that is equal to limit y tends to 0, a minus b into a plus b is a square minus b square, difference of two squares formula you know, correct? So root of 1 plus y power 4 square, the outer root is gone, correct? Squaring this, so I'll write without the outer root, root of 1 plus root of 1 plus y power 4 minus root 2 square is 2, correct? A minus b into a plus b square minus b square divided by y power 4 into root of 1 plus root of 1 plus y power 4 plus root 2. So like this I'm getting. So we can simplify the numerator, right? 1 minus 2 is minus 1 there. So this is equal to limit y tends to 0. What I'm going to get now, root of 1 plus y power 4 minus 1 divided by y power 4 into root of 1 plus root of 1 plus y power 4, correct, plus root 2. Now if you apply limit, still it is in the 0 by 0 form. If you want, you can apply the limit and see whether the indeterminate form is removed or not. Still 0 by 0 form is existing there. Our main aim is to remove that 0 by 0 form. So once again I'm going to rationalize this numerator, multiply and divide by root of 1 plus y power 4 plus 1 divided by the same thing, root of 1 plus y power 4 plus 1. In the numerator, again apply the formula a minus b into a plus b, which is a square minus b square. Hope you understand. A is root of 1 plus y power 4 and b is 1, correct? A minus b into a plus b, a square minus b square, that is root of 1 plus y power 4 square minus 1 square. Root of 1 plus y power 4 square is 1 plus y power 4, correct? 1 plus y power 4 minus 1 I'll get in the numerator, correct? That's equal to, I'll write here, limit y tends to 0, what we had in the last step, like this we had, correct? A minus b into a plus b, I'm going to write a square minus b square, that is root of 1 plus y power 4 square will be 1 plus y power 4 minus 1 square is 1, so 1 plus y power 4 minus 1, correct? 1 plus y power 4 minus 1 divided by y power 4 into root of 1 plus root of 1 plus y power 4, correct? This is what we had, correct? Plus root 2, correct? Root of 1 plus y power 4 plus root 2 plus root 2. Then what we had? Root of, this is already multiplied, in the denominator is root of 1 plus y power 4 plus 1, correct, into 1 by root of 1 plus y power 4 plus 1, right? This is what we had. So now here plus 1 minus 1 will simplify to 0. So what is left out is limit y tends to 0, limit y tends to 0, y power 4 divided by y power 4 into root of 1 plus root of 1 plus y power 4 plus root 2, correct, into 1 by root of 1 plus y power 4 plus 1. This is what we have. Y power 4 is cancelling here. Now we can apply the limit at this stage, so that 0 by 0 form is removed. 1 by root of 1 plus root of 1 plus 0, putting y equal to 0, plus root 2, correct, into 1 by root of 1 plus, putting y equal to 0, plus 1. So what you get is equal to 1 by root 1 is 1, 1 plus 1, 2, root 2 I am getting here, root 2 plus root 2 into 1 by root 1 is 1, 1 plus 1 is 2, correct, this is equal to root 2 plus root 2 is 2 root 2, 1 by 2 root 2 into 1 by 2. Answer is 1 by 4 root 2. This is the answer. Hope you understand. A simple question on limits. Just multiply and divide with the conjugate. Twice you have to apply rationalization and remove the 0 by 0 form to get a finite answer. 1 by 4 root 2. Question asked and the solution is given here. Answer is D, 1 by 4 root 2. If you want, you can take a screenshot of the solution. The textual solution is also given to you. Move on to the next one. Question asked on finding the left hand limit. X belongs to R. The greatest integer function is given. Question asked on 9th January 2nd shift 2019. Okay. And x tends to 0 minus is given. X into, this is greatest integer value of x plus mod x into sine of greatest integer value of x divided by mod x. So this is what you have to find out. The left hand limit at x equal to 0 is asked of this function. So whenever there is modulus function or greatest integer function, what we are going to do is, I'll use one simple technique here. As x tends to 0 minus is given, no, I'll put x equal to 0 minus h, where h tends to 0. Okay, put x equal to 0 minus h, because 0 minus means what? It is slightly less than 0, right? Slightly less than 0. So put x equal to 0 minus h. 0 minus h means what? Minus h. Put x equal to minus h, where h is tending to 0. Where h is tending to 0. 0 means 0 plus only. It's understandable. H is a small positive quantity. So wherever there is x, no, you put minus h. Where h is a small positive quantity, that means 0 minus. X tends to 0 minus means put x equal to 0 minus h, where h is small positive quantity. Suppose I ask x tends to 1 minus. Suppose I ask the question as x tends to 1 minus. What do? You put x equal to 1 minus h, where h is small positive quantity. Understood? Suppose I ask x tends to 3 plus. 3 plus if I ask, then you put x equal to 3 plus a small positive quantity. That becomes easy for us. Okay, this is the idea I'm going to use now. So instead of x tends to 0 minus, I'll put h tends to 0, and wherever there is x, you put minus h. Is that clear? So limit h tends to 0. Alright, limit h tends to 0. Wherever there is x, you put minus h. 0 minus h is minus h. So in place of x, you put minus h into bracket greatest integer value of x is. So greatest integer value of minus h plus mod of minus h sine of greatest integer value of minus h, correct, divided by mod of minus h. Wherever there is x, you put minus h, because x tends to 0 minus means slightly less than 0. That is, put x equal to 0 minus h, where it's a small positive quantity. Hope you understand this. So now h tends to 0 is that whenever there is modulus function and greatest integer function, first you have to evaluate that at that point. H tends to 0. 0 means 0 plus. It's understandable. I won't write 0 plus again. So understand that h is a small positive quantity, say 0.1. So when you put h equal to 0.1, what is greatest integer value of minus 0.1? We know integral value of minus 0.1 is minus 1, right? So first to evaluate this greatest integer function, and mod of minus h is same as mod h, and mod h is h because h is positive, right? Note that mod of minus h is same as mod h, and mod h is equal to h because h is a small positive quantity, right? So mod of h will be h, and greatest integer value of minus h, no, as h tends to 0, as h tends to 0, greatest integer value of minus h will be equal to minus 1. Hope you understand. H tends to 0 means you take a number in your mind that h equal to 0.1. What is integral value of minus 0.1? That is minus 1, right? Minus 0.1. Which are the integers less than minus 0.1? Minus 1, minus 2, minus 3, many other. Among them the greatest is minus 1. Hence the greatest integer value of minus h is minus 1. I am using these two here. Okay. So this is equal to limit h tends to 0, limit h tends to 0, minus h you keep as it is, open a bracket, integral value of minus h as explained here, it is equal to minus 1, and mod of minus h is same as mod h. Mod h is h because h is positive. Sign of, again, greatest integer value of minus h, already given that, minus 1, divided by denominator, mod of minus h is same as mod h. Mod h is equal to h because h is positive. H will cancel, right? Sine of minus 1 is minus sine 1. Sine of minus theta is minus sine theta, right? We know sine of minus theta is equal to minus sine theta. Okay, I'll be doing all the trigonometry part also, don't worry. I'm a new YouTuber, trust me, I'll be doing all the videos connected to PU mathematics. First PU, second PU, it might be NCERT textbook or exemplar or PYQs of JEE or NDA or KCET, or it might be BITSAT or IISER, various competitive exams. One by one I'll be covering, don't worry. Trust me, you can subscribe to my channel, you can forward to all your friends, and if you're a teacher also it's quite useful. Many of the teachers also can watch and gain knowledge from this. Okay, h is going to cancel, so minus 1 remains there. Sine of minus 1 is minus sine 1, correct? This h shall cancel, so what is left is there minus 1, correct? So limit h tends to 0, still limit is there, h tends to 0, alright, minus 1 into, this is minus 1 plus h into sine of minus 1 is minus sine 1, correct? Now we can apply the limit h equal to 0, this will become 0, right? H equal to 0, you put minus 1 into minus 1 plus 1 into minus sine 1, that is minus sine 1. So answer is minus sine 1. Option D is the answer. Hope you understood this. Very simple question. In 2019, I think 3 questions are asked on the modulus and greatest integer function. Many concepts were explained in the previous video, correct? About the limits. It might be sandwich theorem, or it may be 1 to the power infinity, or it may be L'Hopital's rule, series expansion, Maclaurin series expansion, correct? Various concepts were explained in the previous synopsis part of the video, correct? Now I'm doing the JEE part of this, all the PYQs of 2019. So hope you understood this question. If you want the solution, the textual solution is also given to you, minus sine 1. If you want, you can take a screenshot. Also, I'll be uploading the PDF of this, nothing to worry. The detailed solution is given to you. If you look at the various books that are available in the market, correct, PYQ books, but many times what they do is they will skip the steps. They'll skip the steps, they may not write the solution in detail, and sometimes they'll write the answer directly. So such things are found in many books, correct? But in this I'm giving the detailed solution, okay? And also the PDF will be sent to you. All the question solutions will be PDF will be sent will be uploaded in the YouTube also, okay? So nothing to worry. Go on to the next one. Third question. For each t belongs to R, they have given the greatest integer, square bracket of t denotes the greatest integer less than or equal to t. Want to find limit x tends to 1 plus. 1 plus means right hand limit at x equal to 1. They are asking right hand limit of this. This also involves the modulus function and the greatest integer function, correct? Question asked on 10th January, first shift 2019. Okay, various options are given. So x tends to 1 plus. 1 plus means what? Slightly greater than 1, correct? 1 plus a small positive quantity. So what I'll do is I'll put x equal to 1 plus h. In the previous question they asked x tends to 0 minus. Then I put x equal to 0 minus h where x tends to 0. Here x tends to 1 plus is asked, no? So I'll put x equal to 1 plus h where h is small positive quantity. Put x equal to 1 plus h. Put x equal to 1 plus h. Okay, where h is a small positive quantity, where h tends to 0. 1 plus a small positive quantity is indication of 1 plus. 1 plus means slightly greater than 1. Now wherever there is x, you blindly put 1 plus h, and instead of x tends to 1 plus, you take the limit as h tends to 0. So given limit, I'll write like this: limit h tends to 0, limit h tends to 0, okay, 1 minus, in place of x you put 1 plus h, mod of 1 plus h, mod of 1 plus h, correct, plus sine of mod of 1 minus of 1 plus h, correct, bracket closed here, multiplied by sine of pi by 2, greatest integer value of 1 minus, in place of x you put 1 plus h, correct, divided by mod of 1 minus, in place of x you put 1 plus h, greatest integer value of 1 minus x you put 1 plus h, like this. Now simplify it. 1 plus h is positive, right? Because h is a small positive quantity. 1 plus h also small, a number which is positive, I can tell. 1 plus small positive quantity is 1 point something. So 1 plus h is positive. Mod of 1 plus h, I can write 1 plus h because 1 plus h itself is positive. So I'll remove this modulus function now. Is equal to limit h tends to 0, 1 minus, mod of 1 plus h is 1 plus h, bracket 1 plus h, correct, plus sine of, here 1 minus 1 is 0, inside the mod 1 minus 1 0, minus into plus minus h, sine of mod of minus h, sine of mod of minus h. Mod of minus h is same as mod h. Mod h is h because h is a small positive quantity. Close the bracket here, and that is multiplied by sine of pi by 2 times greatest integer value of 1 minus 1 is 0, minus into plus minus h. As explained in the previous problem, I'll be using the greatest integer value of minus h as minus 1. Already explained in the previous problem also. Mod of 1 minus 1 is 0. Here minus into plus becomes minus. Mod of minus h. Here 1 minus 1 0. What I'm getting is integral value of minus h. Correct? Now, here 1 minus 1 becomes 0 here. Bracket, simplify this. 1 minus 1 0. Minus into plus becomes minus. Minus h. Correct? This is equal to limit h tends to 0. What I am getting here is minus h. Mod of minus h same as mod h. Mod h is h because h is positive. So plus sine h into sine of pi by 2 into integral value of minus h is minus 1. As h tends to 0, imagine a small positive number h equal to 0.1. Integral value of minus 0.1 is minus 1. Pi by 2 into minus 1 it becomes. So this becomes sine of pi by 2 into minus 1, that is minus pi by 2, correct, divided by mod of minus h same as mod h. Mod h is h because h is positive and integral value of minus h is minus 1. Sine of minus pi by 2 is also minus 1. This minus 1 and minus 1 will cancel, right? So what is left out is this is equal to limit h tends to 0. What I am writing is minus h by h, that is minus 1, plus sin h by h, separating the terms, divide individually. Minus h by h is minus 1 plus sin h by h, sin h divided by h, correct? And sine of minus pi by 2 is minus 1, minus 1 is cancelled out. So, and we know limit h tends to 0, sin h by h is 1, this tends to 1. So what we get? Minus 1 plus 1, answer is 0, equals to 0. Option B is the answer. Hope you understand this. Please practice all these problems. Okay, those are preparing for JEE exams. From now itself you start preparing. First few topics you should learn properly. Trigonometry is very important. Functions, how to simplify modulus function, how to simplify the greatest integer function. Learn all the basic concepts. If you're not understood, you can listen to my classes. I'll be doing all the classes one by one. Okay, even the NCERT syllabus also. For time being, I started with this limits now. The textual solution is also given to you. Answer is 0. If you want, you can take a screenshot of this. Also, I'll be sending you the PDF of all the solutions. Move on to the next one. Again, square bracket x denote the greatest integer less than or equal to x given. Question asked on 11th January, first shift 2019. Okay, limit x tends to 0 is asked. So here also the question involves the modulus function and greatest integer function, right? Modulus function and greatest integer functions are involved. So in this question I need to find left hand limit and right hand limit separately. Whenever there is modulus function, greatest integer function, square root function or fractional part function, signum function or function defined piecewise, in that case I have to find out the left hand limit and right hand limit separately. So I'll find out the left hand limit and right hand limit separately in this problem because the question involves the modulus function and greatest integer function. First we'll find out the left hand limit. Left hand limit is limit x tends to 0 minus, correct? Limit x tends to 0 minus. What we have? Given expression is tan of pi into sine square x plus mod x minus sine of x times greatest integer value of x. This entire thing square, correct? Whole thing is divided by x square. Like this, the question is given. So, use the technique. As x tends to 0 minus means what? Put x equal to 0 minus h, where h is a small positive quantity. Put x equal to 0 minus h. Put x equal to 0 minus h, where h tends to 0. H tends to small positive quantity. Same story as we did in the previous question. Limit x tends to 0 minus means h tends to 0, where x is 0 minus h, that is minus h. Put x equal to minus h everywhere. Blindly put x equal to minus h. Tan of pi into sine square of minus h, correct? Plus mod of x is minus h minus sine of x is minus h into integral value of minus h, correct? This entire thing square divided by, wherever there is x I am putting minus h. Put x equal to 0 minus h because I am finding the left hand limit at x equal to 0. 0 minus means slightly less than 0. 0 minus a small positive quantity, indication of left hand limit at x equal to 0. We know sine of minus h minus sine h square is sine square h, correct? Minus square is plus, and mod of minus h is same as mod h. Mod h will be h because h is a positive quantity. Here integral value of minus h is minus 1. Again, if you understand the concept properly once in mathematics, again the same concept is going to repeat. That's the advantage. If you learn one problem properly, all the problems you can crack. That's the advantage of mathematics. So limit h tends to 0. Limit h tends to 0. What we have here? Tan of, correct? Pi sine of minus h minus sine h. Minus sine h square is sine square h, correct? Sine square h plus bracket mod of minus h same as mod h. Mod h is h because h is positive. Hope you understand the definition of modulus function. And integral value of minus h is minus 1. So this is minus 1, correct? Minus 1 into minus h becomes plus h. So this is minus sine of minus h into minus 1 is plus h. So h minus sine h, the whole square, divided by denominator minus h square is same as h square. Now numerator is sum of two terms. Now you can separate the terms. So divide individually. Okay, separating the terms. What I'll get? I'll write this as limit h tends to 0. Limit h tends to 0. Tan of pi sine square h, correct, divided by h square is there, divided by h square, plus separating the terms, divide this by this plus this by this, h minus sine h the whole square by h square, h minus sine h the whole square divided by h square. I separated the terms, correct, dividing individually. A plus b by c means a by c plus b by, separating the terms. Now we know tan of an angle by same angle is 1. Tan theta by theta is 1 as theta tends to 0. So I won't apply that here. But here the angle is pi into sine square h. You see, as h tends to 0, sine h is also tending to 0. This angle is tending to 0. So I'll multiply and divide by pi into sine square h. And here I can write this as h minus sine h by h the whole square. I can write, correct. I can add one more slide here. Then c equal to limit h tends to 0 tan of pi sine square h by h square, correct. Limit h tends to 0, we had tan of pi sine square h, tan of pi sine square h. I'll divide by pi sine square h multiplied by pi sine square h divided by h square, correct. Divide by h square was there earlier. H square, multiply and divide by pi into sine square h. This I'll write it as h minus sine h by h the whole square. H minus sine h by h the whole square. H minus sine h divided by h, this entire thing square, correct. Now this angle is tending to 0, correct. So tan of an angle by same angle is 1. This entire thing tends to 1. Tan theta by theta is 1. And sine square h by h square is 1, because sine h by h the whole square. Even this tends to 1. 1 square 1. So what is this? Pi into 1. So this becomes pi into 1. This is also 1. 1 into pi into 1 plus here h by h is 1, correct. Limit h tends to 0. I already applied limit for this. Now I am applying limit for this. Limit h tends to 0. Limit h tends to 0. What is this? Separate the terms. Divide individually here. H by h is 1. Correct. Minus sine h divided by h the whole square. Correct. As h tends to 0, sine h by h is 1. So this becomes, this tends to 1. 1 minus 1 is 0. I can apply limit inside this bracket. Correct. Sine h by h is 1 as h tends to 0. So 1 minus 1 is 0. 0 square is 0. So what is we are getting is pi plus 0, which is equal to pi. So left hand limit is pi. So far we did only the left hand limit. Now we'll do the right hand limit for this. Right hand limit. Limit x tends to 0 plus. Limit x tends to 0 plus, because we don't know whether limit exists or not, correct. Because the question is asked limit x tends to 0. We have to find left hand limit and right hand limit separately, because the given expression involves the modulus function and greatest measure function. We have to find out the left hand limit and right hand limit separately. If they are equal, then only we can conclude that limit of the function is going to exist. Equal and finite it should be. Okay. So now I will find out the right hand limit for this. Limit x tends to 0 plus of this expression, tan of pi into sine square x. Limit x tends to 0 plus. Limit x tends to 0 plus of tan of pi into sine square x, correct, divided by x square, correct. The question was like this. I separate the terms and write anyway, okay. Tan of pi into sine square x by x square plus mod x minus sine of x into greatest value of x the whole square plus mod x minus sine of x in times greatest integer value of x the whole square, correct, divided by x square. I separate the term and wrote, okay. This was a question asked, correct. X tends to 0 plus means slightly greater than 0. Value of x is slightly greater than 0. So put x equal to 0 plus h. Put x equal to 0 plus h where h tends to 0. Where h tends to 0. I will be putting x equal to h where h tends to 0. So what we get? Limit x tends to, I should put h tends to 0, no? H tends to 0. I will put h tends to 0 now. Instead of putting x tends to 0 plus, I'll put h tends to 0, okay, h tends to 0 where x is 0 plus h. Wherever there is x, you write 0 plus h. 0 plus h is h. So tan of pi sine square h divided by h square, as we had in the left hand limit. Same type of here. Only this part is going to change here. Correct? 0 plus h. Wherever there is x, you put h. Sine of x, you put h. Integral value of h. Correct? Here. This entire thing square divided by h square. This part is same as we had in the left hand limit. So this part I won't write again. This part will simplify to pi. Correct? Plus here limit h tends to 0. For this limit h tends to 0. Mod of h is h. Correct? Because h is positive. Integral value of h as h tends to 0. Correct? There it was in left hand limit, it was minus h there. So it became sine of minus h. Now as h tends to 0, integral value of h is 0. Correct? Note that as h tends to 0, as h tends to 0 means 0 plus. It's a small positive quantity. Integral value of h will be 0. Integral value of 0.1 is 0. This part is becoming 0, right? H into 0, 0. Sine 0, 0. Correct? H minus 0 the whole square divided by h square. That means I can write it as pi plus limit h tends to 0. H minus 0 is h. H square by h square. Correct? H square by h square is 1. Limit of 1 is 1. So it becomes pi plus 1. Limit of a constant is constant. Left hand limit we got it as pi. Correct? Right hand limit we are getting pi plus 1. So left hand limit is not equal to right hand limit. What is the conclusion? Limit does not exist. Hope you understand this. Remember, this is important. As h tends to 0, integral value of h is 0, and as h tends to 0, integral value of minus h is minus 1. All these things you must learn. Very important skills of the evaluating the greatest integer function. The point to be noted is, as h tends to 0, integral value of minus h is minus 1. As h tends to 0, integral value of h is 0. Take an example if you don't understand. Say take h equal to 0.1 in both the cases. Integral value of minus 0.1 is minus 1. Integral value of 0.1 is 0. Hope you understand this. In all the three questions, in the previous fourth question, third and second, we use this concept of evaluating the greatest integer function. Correct? So learn all these skills. And I can show you the solution also. The solution is given here. We got the left hand limit as pi and right hand limit is pi plus 1. LHL is not equal to RHL. Limit does not exist. Hope you understand this. Move on to the next one. Question number 5. Limit x tends to 0, x into cot 4x divided by sine square x into cot square 2x. Comparatively, this question is quite easy. It's because this question does not contain any modulus function or greatest integer function. Quite very easy question asked. Question asked on 11th January, second shift, 2019. Limit x tends to 0. Limit x tends to 0. I'll write this as x into x by sine square x. I'll write x by sine square x. What I'll do is cot 4x is there, no? I'll bring it to denominator. It becomes tan 4x. Cot 4x, bring it to denominator because 1 by cot is tan or cot is 1 by tan. Cot square 2x in the denominator, take it to numerator. It becomes tan square 2x. If you apply the limit directly, no. What happens is, see, if you want x equal to 0, put 0 and cot of 4 into 0, 4 into 0, 0. Cot 0 is not defined. Cot not defined, or you can take it as infinity. 0 into infinity is also not defined. It's an indeterminate form. Correct? If you apply limit directly, you won't get the answer. It takes indeterminate form. Correct? So I have to use the trigonometric limits here. What I did first, cot 4x I wrote 1 by tan 4x and denominator cot square 2x is taken to numerator as tan square 2x. Now I can use the shortcut. In the previous video I had done the synopsis part of this, right? Directly I can write the answer for this. See, look at the powers of sine and tan here. Power of tan is 2. Here power of x 1, correct? So sum of the powers of tan and x is 2 plus 1, 3, numerator. Denominator, sum of the powers of sine and tan, how much? Sine power is 2, tan power is 1, right? So directly, sum of the powers of sine and tan in the numerator, denominator is same, right? 2 plus 1, power of tan is 2, power of x is 1. Here power of sine is 2, power of tan is 1. So I can write the answer directly as, what is the coefficient of x? 1 here. What is coefficient of x2? So 2 square. Square is there, correct? Here coefficient of x 1, so 1 square, and here coefficient of x is 4, so how much? Answer 4 divided by 4 is equal to 1. Over. You can crack the answer. Answer is option D. If you not understood this method, I can do it proper method also. It takes little more time. At least 5 questions will be of this type in the entire paper. I can give you guarantee about this. Out of 25 questions, minimum 5 questions will be of this type, of all various concepts. They may not ask the easy question on limits only. I can't give that guarantee. Okay, but in the overall paper, out of 25 questions, 5 questions you can crack it in very less time. Within 2 minutes you can finish those 5 questions. Such kind of questions will be there. Okay, in almost all papers I can give guarantee. If you not understood this method, I'll do the proper method. Okay, for those who are not understanding this. Limit x tends to 0. Hope you understood this step. Writing cot as 1 by tan. This step you understood from this step. This step is understandable for everyone. I'll make use of the theorems. 2 familiar theorems you learned first PU, right? Sin x by x equal to 1 as x tends to 0, and tan x by x equal to 1 as x tends to 0. X is measured in radian using that concept. X divided by sin square x is there. No, there you multiply and divide by x square. Divide by x square, multiply by x square. Okay. Tan square 2x means what? Tan 2x into tan 2x, right? Tan 2x into tan 2x. Here you divide by 2x, divide by 2x. So to balance it, multiply by 4x square. Divided by denominator tan 4x, tan 4x. Divide by 4x, multiply by 4x. Tan of an angle by same angle is 1, right? Sin of an sin x by x 1. This becomes 1 square. This part is 1. Correct? Here this part is 1. Tan of an angle by same angle is 1. Tan of an angle by same angle is 1. Tan 4x by 4x is 1. So what is left out here? 1, 1, 4x square. 4x square into x becomes 4x cube. Numerator is 4x cube. Denominator 4x into 1 into x square. 4x into x square. 4x cube. Correct? X cube is going to cancel. 4 cancels. Limit of a constant is constant. If you can't understand this shortcut method, you can do the actual method. Still it doesn't take much time. Hardly 20 seconds. Correct? Simple question. Correct? Asked on 11th January, second shift 2019. Move on to the next one. I shall show you the textual solution also. The solution is given to you here. And next step, next question will go on to the next one. Number 6. X tends to pi by 4. Cot cube x minus tan x divided by cos of x plus pi by 4. A trigonometry function is given to you. If you apply the limit directly, what happens? Put x equal to pi by 4 directly. What is the value of cot pi by 4? Cot pi by 4 is 1. 1 cube is 1. Correct? Tan pi by 4 is 1. 1 minus 1. 0. Numerator becomes a denominator. Put x equal to pi by 4. Pi by 4 plus pi by 4 is pi by 2. Cos pi by 2 is 0. Correct? 0 by 0 form. You can apply L'Hopital's rule here. Can apply L'Hopital's rule because it takes 0 by 0 form. Not every time I'll apply L'Hopital's rule when it takes 0 by 0. In this problem, it's easy to apply L'Hopital's rule, so I'm applying it. Because it takes 0 by 0 form, I can apply L'Hopital's rule here. Apply L'Hopital's rule. What does L'Hopital's rule says? Differentiate the numerator and denominator separately. Apply L'Hopital's rule. Hope you know the chain rule also here. And those are preparing for any competitive exams, study both first PU and second PU topics in first PU itself. That's a huge advantage because many times the topics are linked from one topic to another topic. They are linking. Correct? So it interacts one chapter to another chapter. Question can be connected. So you must know what is chain rule, how to differentiate a composite function. So the best way of preparing is those who finish 10th standard. I'm telling you, when you come to first PU, finish off the first PU syllabus entirely within 3 months. You should be very studious. You should not waste much time at all. Within 3 months, June, July, August. By August 15th or by August 10th, you finish off the entire first PU syllabus, all PCMB. Okay, then start second PU syllabus soon after that. September, October, November. By first PU November month, you should finish off the entire first PU and second PU. December onwards, 1 month you can revise. Okay, then January you can start the competitive exams. By that time, you will get first PU for an exams. Correct? And after first PU for an exams, again another 15 days we can just revise both first PU and second PU quickly, and then you start competitive full from March itself. From March till December, from March till December you can work out all competitive exams questions. So you should be thorough with NCERT book. If you're not thorough with NCERT book, it's a waste. Okay, First, master the NCERT book. That's most important. Now I'm applying L'Hopital's rule. L'Hopital's rule is applicable for 0 by 0 or infinity by infinity form only. Okay, because it takes 0 by 0 form, I'm applying L'Hopital's rule in this problem. And that L'Hopital's rule says that you differentiate the numerator and denominator separately. Differentiate the numerator, derivative of cot cube x. Differentiate as a differentiate x cube. I'm applying chain rule there. Correct? 3 cot square x. 3 cot square x into derivative of cot x, that is minus cosecant square x, correct? Minus derivative of tan x is secant square x. Derivative of x cube, 3x square, 3 cot square into derivative of cot is minus cosecant square. Derivative of cos is minus sine of x plus pi by 4 into derivative of x plus pi by 4 is 1, correct? Applying chain rule. And now we can apply the limit here. What do we get? Minus, I'll write first, minus 3 cot square pi by 4. Cot pi by 4 is 1. Applying the limit. Wherever there is x, you put pi by 4. Pi by 4 is 1. 1 square. Cosec pi by 4 is root 2. Root 2 square. Minus is already written there. And this is secant pi by 4. Secant pi by 4 is root 2 square. Simple question. This also quite easy. Minus, here put x equal to pi by 4. Pi by 4 plus pi by 4, pi by 2. Sin pi by 2 is 1. Correct? So what do you get? This is equal to root 2 square is 2. 2 into 3, 6. So minus 6. And this is minus 2 divided by minus 1. This is minus 8 divided by minus 1 is equal to 8. Very simple question. Can be asked even in CET exam also. Level 0 kind of question for JEE exams. Just differentiate the numerator and denominator, then apply the limit. L'Hopital's rule is helpful here. 0 by 0 form. 8 is the answer, option D. The textual solution is also given to you. Answer is 8. If you want, you can note down this. You take a screenshot if you want, or else I'll send you the PDF also of this solutions. Detailed solution. And question number 7 is given like this. Question asked on 12th January, second shift, 2019. Limit extends to 1 minus. Limit extends to 1 minus is given. If you apply limit directly, here also it takes 0 by 0 form, okay? Put x equal to 1, sin inverse of 1, how much? Pi by 2, correct? You must know the inverse trigonometry function also. That's why it links one topic to another topic. That's why I'm telling, study both first PU and second PU entirely in first PU itself. Okay, finish off the NCERT syllabus. Okay, and also you can learn even that you can work out even level 1 kind of questions in first PU itself, and maturity also gets improved. When you come to second PU, understanding the competitive exam level questions becomes easier because mind maturity or the IQ power also increases. Okay, when you come to second PU, when you are in first PU, it's not so easy to understand because you're new to the college level. From 10th standard to first PU, it's not so easy to get adjusted to the syllabus of the PU syllabus, correct? So it takes time. Whenever you come from high school to college, it will take a little time to get adjusted. So my suggestion is you finish off the first PU and second PU entire syllabus in first PU itself. Don't prepare for first PU final exam. If you're preparing for competitive exam like JEE, okay, you should be very serious. You need to work hard and hard. You have to work out minimum 10 questions per day in each subject when you come to second PU. Hope you studied entire first PU syllabus and second PU syllabus in first PU itself, and when you enter to second PU and you're in second, when you are in second PU, you'll be working only the competitive exam questions with mastered NCERT. Hope you mastered NCERT, you'll be working only the competitive exam questions. Okay, it might be JEE or CET. In that case, if you're working out every day, you work out 10 questions or 15 questions per day. So throughout the year, and by 1 month or 2 months, if you're practicing 10 questions per day, automatically it will increase. The speed also gets increased. Okay, so all those things you should learn. Okay, how to learn, the way of learning also you should know, not simply studying somehow for namesake. Don't do such things. Extends to 1 minus. Sin inverse of 1 is pi by 2. 2 into pi by 2 is pi. Correct? Becomes root pi. Correct? Minus root of 2 into sin inverse of 1 is pi by 2. 2 cancels. Correct? Denominator is root of 1 minus 1. Correct? Root pi minus root pi 0. 1 minus 1 0. Root 0 0. 0 by 0 form. I can apply L'Hopital's rule here. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. L'Hopital's rule. Because it takes 0 by 0 form, it is easier for us to differentiate numerator and denominator separately. X tends to 1 minus means left hand limit. Anyway, this expression does not contain the modulus function or greatest integer function. No need to find out. I mean, they ask only the left hand limit. Of course, if they ask x tends to 1 plus, I can't find out. 1 plus becomes meaningless. See, 1 plus means what? Slightly greater than 1, right? If you put a value of x slightly greater than 1, 1 minus 1.1 becomes root of negative. It's not possible. That's why they ask only left hand limit here, correct? X tends to 1 minus. Derivative of root pi is constant. Derivative of constant is 0. And derivative of root x is 1 by 2 root x. 1 by 2 root of whatever is given. Same thing, right? 1 by 2 root x into derivative of terms inside the root. Derivative of 2 sin inverse of x. 2 into derivative of sin inverse x. 1 by root of 1 minus x square. Denominator also differentiate. Derivative of root is 1 by 2 root. 1 by 2 root of 1 minus x into derivative of 1 minus x is minus 1. Correct? We can cancel this 2 and this 2 will cancel. Our main aim is to remove the indeterminate form. We are getting 0 by 0 indeterminate form. Our main aim is to remove that indeterminate form. Keep it in mind. That is the important part of the story. Correct? So you must know what we are doing. If you forget what we are doing, then it's of no use. So this 2 has been cancelled. This minus also cancel. Make it plus. Okay. So what is left out now? 1 by root 2 into root of sin inverse x. Correct. And here 1 square is 1. No. 1 is same as 1 square. A square minus b square. I can split a plus b into a minus b. So this will be 1 by root 1 minus x into 1 by root of 1 plus x. Because 1 minus x into 1 plus x, 1 minus x square. Denominator minus has been cancelled. I won't write again that minus, divided by 1 by 2 root of 1 minus x, and I can cancel these common terms. 1 by root of 1 minus x is cancelled, and you can apply limit at this stage. This 2 will go up, correct? Denominator goes to numerator. This 2 is gone up. 2 divided by root 2, and sin inverse of 1 is pi by 2, so root of pi by 2, and here put x equal to 1 by root of 1 plus 1, that is root 2. Correct? Root 2 into root 2 becomes 2. That 2 will cancel with this. So 1 by root of pi by 2, that is root of 2 by pi. Answer is root of 2 by pi. Option D is the answer. This is also a simple question, quite simple one. Just applying L'Hopital's rule, but you must know the formula for derivative of sin inverse of x. You must know the chain rule here. And we were getting that indeterminate form because of this factor 1 by root of 1 minus x, that has been cancelled out, so that indeterminate form is removed. Hope you understand this. Please make a note of this, and also the solution is given to you here. Root of 2 by pi. Option D is the answer. Root of 2 by pi is the answer. Correct? Move on to the next one. This is from 2019 April. 7 questions were asked in January shift, and the remaining 6 are from April shift. This is question number 8, 2019 April. Can you do this? This is a simple question. If you apply the limit directly here, x equal to 0, sin 0, 0, 0 square 0, correct? Numerator becomes 0, denominator is root 2 minus, here put x equal to 0, cos 0 is 1, 1 plus 1 to root 2, correct? Root 2 minus root 2, 0, 0 by 0 form. You can apply L'Hopital's rule. Differentiate numerator, denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. Limit x tends to 0. Derivative of sin square x. Derivative of sin square x is, you should apply chain rule. 2 sin x, differentiate as a differentiate x square. Derivative of x square is 2x. Derivative of sin square x is 2 sin x into derivative of sin x is cos x. Denominator also differentiate. Derivative of constant is 0. Derivative of root x, 1 by 2 root x. 1 by 2 root of 1 plus cos x. Derivative of 1 plus cos x, that is minus sin x. We are getting 0 by 0 form because of the factor of sin x here. Sin x will cancel, okay? X tends to 0 means x is not exactly 0, x is approaching 0. You should understand the concept of limit properly. Minus into minus will become plus. This 2 will go up. So what you get is limit x tends to 0, What we have, this 2 goes up, 2 into 2 4, minus into minus became plus, denominator goes to numerator, root of 1 plus cos x into cos x, correct? Like this we get, put x equal to 0 now, 4 into root of 1 plus cos 0 is 1, correct, into cos 0 is 1, answer is we get 4 root 2. Cos 0 is 1, cos 0 is 1 plus 1 to root 2, root 2 into 1, root 2 into 4, 4 root 2. Quite simple question on applying L'Hopital's rule and getting the answer. 4 root 2 is the answer, option C. Next comes the question on Newton-Leibniz formula. Integration is there, that's what I told. See, inverse trigonometry function we had one question, chain rule we want, and here comes integration. So if you're in first PU, it becomes difficult because you're not aware of integration entirely. That's what I suggest. You study both first PU and second PU topics entirely in first PU itself, then come to competitive questions. Then you can do all questions easily. Okay. Learn the synopsis part. Synopsis is very important always. Your synopsis should be very strong. Then only you can crack any question. Without knowing the formulas, it is not useful at all to listen to the class, or if you are not working out, it is completely waste. F of 2 is equal to 6. F from R to R is a differentiable function. F of 2 is given as 6. You have to find limit x tends to 2. Integral from 6 to f of x. Lower limit is 6 and upper limit is f of x. 2t dt by x minus 2 is given. What is given? Limit x tends to 2. Limit x tends to 2. Correct? Integral from 6 to f of x. Lower limit is 6. Upper limit is f of x. 2t dt. 2t dt divided by x minus 2. If you apply the limit directly, no, it takes 0 by 0 form. See, denominator x you put 2, 2 minus 2, 0, no? And I can write this as limit x tends to 2, limit x tends to 2, I can separate and write. Numerator is integral from 6 to f of x, 2t dt, this is numerator, and denominator is x minus 2, okay, like this. Write numerator by denominator separately. Integration sign is only for numerator because with respect to t, no, t is present only in the numerator. You should understand the question properly. Denominator does not contain t. Denominator is only function of x. Can separate the numerator and denominator. And integration sign is only for numerator because dt is present. Means the variable for integration is t. T is the variable for integration, and the integral upper limit is a function of x, correct? So overall, if you integrate and get the answer, no, it will be a function of x. So numerator is function of x, denominator also function of x. But for integration, the variable is t. So I am separating and writing. If you apply the limit, no, here this becomes f of 2. When you apply limit x tends to 2, this becomes f of 2. What is f of 2 is given? F of 2 is 6. So integration from 6 to 6 it becomes. When you apply limit for numerator, understand properly, when you apply limit x tends to 2, this becomes f of 2, right? This becomes f of 2. F of 2 is given to be equal to how much? 6 in the question. So integral from 6 to 6. Integral from 6 to 6 is always 0. Integral from a to a is 0, correct? Lower limit and upper limit is same, means integration value is going to be 0. Okay, you must know that thing first. So this numerator is becoming 0 when you apply the limit. Denominator also becomes 0 when you apply limit. X tends to 2. Understood? X tends to 2. X is approaching 2. So when x is approaching, this becomes f of 2. What is f of 2 is given in the question? F of 2 is given to be equal to 6. So this becomes integration from 6 to 6. Integration from 6 to 6 of any function is 0 only. Because lower limit and upper limit is same, means integration value is 0. That you must know, the basic concept. So numerator is becoming 0, denominator is becoming 0 when you apply the limit. So it takes 0 by 0 form, I can tell. It takes 0 by 0 form. When it takes 0 by 0 form, we can apply L'Hopital's rule. L'Hopital's rule says that you differentiate the numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule because it takes 0 by 0 form. I am differentiating the numerator and denominator separately. And to differentiate the numerator, I am applying Newton-Leibniz formula. Okay. I am applying Newton-Leibniz formula. Right here, remaining part. Limit x tends to 2. Correct. D by dx. I am differentiating the numerator. Integral from 6 to f of x, what we have 2t dt, and denominator also differentiate d by dx of x minus 2. Differentiate the numerator and denominator separately. Now at this stage I am applying the Newton-Leibniz formula. Already I have explained that in the synopsis, how to differentiate a definite integral. Newton-Leibniz formula tells you that how do you differentiate a definite integral. This is a definite integral because there is lower limit and upper limit. So when you differentiate an integral, the integration and differentiation is going to cancel out. The limit x tends to 2, integration and differentiation is going to cancel out. What I am going to get is 2 into, write the upper limit in place of t. What is the variable for integral? The variable for integral is t. In place of t, put the upper limit 2 into f of x. What is upper limit? F of x. In place of t, you put the upper limit because for integration the variable is t, correct? In place of the variable t, you put f of x. Substitute the upper limit, differentiate the upper limit, correct? In place of t, you put the upper limit f of x into derivative of f of x minus 2 into, put the lower limit. In place of t, you put the lower limit. What is lower limit? 6 into 6 into derivative 6, 0, correct? Divided by denominator, differentiate, derivative of x minus 2, derivative of x1, derivative of 2, 0, correct? So how to apply Newton-Leibniz formula? When you differentiate a definite integral, what happens? Integration and differentiation is going to cancel out. Substitute the upper limit into derivative of upper limit minus substitute the lower limit into derivative of lower limit. Hope you understand. Substitute the upper limit in place of t, put f of x into derivative of f of x, which is f dash of x, minus 2 into, substitute the lower limit 2 into 6 into derivative 6, 0. Correct? So what do you get? Now 2 into f of 2 into f dash of 2. 2 into 6, 12, 12 into 0, 0. That part is 0. Divided by 1. And f of 2 is given as 6. Now I can substitute here. F of 2 is given to be equal to 6. 6 into 2, 12. So answer is how much? 12 into f dash of 2. That's the answer. Option B is the answer. Hope you understand this. How to apply Newton-Leibniz formula. This is a very familiar question. Many times questions are asked on L'Hopital's rule and Newton-Leibniz formula, a combination of both. Okay, please practice it. All these things are very easy, nothing difficult. All these things very easy. You should practice. Practice is required every time. Okay. Solution is given to you. The textual solution is given here. If you want, you can make a note of this. If you want, take a screenshot of this. Also, I'll be sending you the PDF of all these things. Okay. Move on to the next one. Question number 10. This is a very simple question asked. We have to find the value of k. Question asked on 10th April 1st shift 2019. Both sides of left hand side and right hand side of this equation takes a 0 by 0 form. You can apply L'Hopital's rule and get the answer. Same question is found in NCERT exemplar book. Okay. Please make a note of this. It's found in NCERT exemplar book. Same question. Okay. Now if you apply limit x equal to 1, 1 power 4, 1, 1 minus 1, 0, correct? Denominator also 1 minus 1, 0, 0 by 0 form. Here put x equal to k cube minus k cube, 0, correct? K square minus k square, 0, 0 by 0, 0 by 0. Apply L'Hopital's rule. Differentiate numerator and denominator separate. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Limit x tends to 1. Differentiate x power 4, 4x cube. Derivative of 1, 0. Divided by derivative of x, 1. Derivative of 1, 0. Here, limit x tends to k. Limit x tends to k. Derivative of x cube, 3x square. Derivative of k cube is 0. K is a constant. K cube is constant. Derivative of constant is 0. Denominator, differentiate derivative of x square, 2x. Derivative of k square, 0. Apply limit x equal to 1. 4 into 1 cube, 1. Correct? Here, put x equal to k. 3k square divided by 2k. Correct? So what do you get? 4 is equal to 1k is going to cancel. 3k divided by 2. Or 8. 4 2s are 8. 8 is equal to 3k and cross multiplication. So k is equal to 8 by 3. Very, very simple question. Asked on 10th April 1st shift 2019. Value of k is 8 by 3. Differentiate numerator and denominator separately for even the left hand side and right hand side. and get the value of k. Hope you understand this. K is a constant, k cube is a constant, derivative of constant is 0. Solution is given to you. Next, move on to the question number 11. Limit x tends to 1, x squared minus ax plus b by x minus 1 equal to 5. Find a plus b equal to how much? Question answered on 10th April, 2nd shift, 2019. This is a different type of question. Even this type of concept is explained in the synopsis part. See, as x tends to 1, as x is approaching 1, what happens? Denominator is becoming 0, right? When you put x equal to 1, 1 minus 1 is 0. Denominator is approaching 0. If denominator is approaching 0, then numerator also should approach to 0. Correct? As x approaches 1, if denominator is becoming 0, numerator also should become 0. Suppose numerator is non-zero. Suppose numerator is 100, you see. See, as x is approaching 1, denominator is becoming 0. If denominator is becoming 0, suppose numerator is 100. Imagine that numerator is 100 or 10, some other number. So 100 by 0, can it become equal to 5? Not possible, right? So because limit is already given to be equal to 5, limiting value is already given to be equal to 5, that means limit of the function is going to exist finitely, correct? So as denominator is becoming 0, numerator should become 0 so that it takes 0 by 0 form. Suppose numerator is not 0, denominator is becoming 0 already, correct? As you put x equal to 1, 1 minus 1, 0. Denominator is becoming 0. Denominator is approaching 0. Suppose numerator is not becoming 0. Non-zero by 0 can't be equal to 5. Correct? It becomes a contradiction to the given statement. So, what we have is, as x approaches 1, because denominator is tending to 0, numerator should tend to 0. That is what we insist. Because limit is a finite number. Whenever limit is a finite number, this is a condition. Finite non-zero number, that too here, correct? If denominator is approaching 0, numerator should approach 0. So if numerator is approaching 0, you put x equal to 1 in the numerator and equate it to 0. You'll get, there are two constants here, a and b. I have to find a plus b, no? There are two constants a and b to be found. So I need two equations somehow. Correct? That's a basic idea in mathematics. If you want to find two constants a and b, we need two equations, right? So one equation I can construct by using this condition. As x is approaching 1, denominator is becoming 0, so numerator should become 0, correct? So I'll use that. Put x equal to 1 in the numerator and equate it to 0. 1 square minus a into 1 plus b is equal to 0. So what we get? B minus a is equal to minus 1, equation 1. And because it takes 0 by 0 form, I'll apply L'Hopital's rule. Okay, because it takes 0 by 0 form, apply L'Hopital's rule. One can apply L'Hopital's rule, I'll write LH rule in short. Apply L'Hopital's rule. What do we get? Limit x tends to 1. Differentiate the numerator. Derivative of x square is 2x. Derivative of ax is a. Derivative of b is 0. Differentiate the denominator. Derivative of x minus 1, 1 minus 0 is equal to 5. Correct? Now apply limit for this. X equal to 1. 2 into 1, 2. 2 minus a by 1. So I am getting 2 minus a is equal to 5. Correct? From this minus a take the answer becomes plus a. A is equal to 2 minus 5 minus 3. So value of a is minus 3. Put a equal to minus 3 in equation 1. Put a equal to minus 3. Put a equal to minus 3 in equation 1. We'll get the value of b. Right? B is how much? B is minus 1 plus a. Minus 1 plus a. That is minus 1 plus a is minus 3. Minus 3 minus 1 minus 4. They asked to find a plus b. Therefore, a plus b is equal to how much? A is minus 3. B is minus 4. Minus 3 minus 4 minus 7. Option C is the answer. So learn this concept, important. If x tends to 1, denominator is approaching 0, numerator should approach to 0 so that it takes 0 by 0 form. This is a concept useful when the given limit is a finite number. This type of concept is already explained in the synopsis part also. Once in KCET also this type of question was asked, and in NCERT book also there is one question I can tell you. I remember, limit x tends to 1, f of x minus pi divided by x square minus 1 is equal to 5, something like that question is there. Okay, NCERT book there is one question similar to this. Okay, there also they ask a question based on this only. Okay, so please make a note. This is a commonly asked question. This type of concept question, many times the questions are asked in JEE exams, and the solution is given to you. A plus b is minus 7. Next one, again integration sign is there. Whenever integration sign is there, limit is there, you should apply Newton-Leibniz formula, L'Hopital's rule and Newton-Leibniz, combination of both. You see integration sign, you see that limit is there. Most of the time I can give guarantee that two combo of L'Hopital's rule and Newton-Leibniz formula. So f of 2 is given to be equal to 6, f dash of 2 is equal to 1 by 48. Question asked on 12th April 1st April 2019. Okay, f dash of 2 is given, f of 2 is given. So integration sign you can see here, correct? From this you find what is g of x. Look at this equation given to you. From this you write what is g of x, because you want to find limit x tends to 2 of g of x. What is g of x from this? G of x is equal to integral from 6 to f of x 4t cube dt, correct, divided by x minus 2. I can write g of x like this. And for integration the variable is t, correct? And integration, after you integrate it and apply the limits, lower limit, upper limit, it will be a function of x. So numerator is function of x, denominator also function of x. So g of x, is that clear? Now I have to find limit x tends to 2 of g of x. If you apply limit here, limit x tends to 2 of g of x is equal to limit x tends to 2, integral from 6 to f of x 4t cube dt divided by x minus 2. When you apply limit, what happens? Denominator is becoming 0, no? 2 minus 2, 0. Numerator, apply limit x equal to f of 2. What is f of 2? F of 2 is given to be 6. Integration from 6 to 6. As I told earlier, integral from a to a is 0. So numerator is becoming 0, denominator is becoming 0, 0 by 0. When I apply the limit, it takes 0 by 0 form. So we can apply L'Hopital's rule. Takes 0 by 0 form, correct? Again I repeat, as x approaches to, denominator is becoming 0, 2 minus 2, 0. Numerator, what happens? Integral from 6 to f of 2. Correct? When you apply x approaches to, this becomes f of 2. F of 2 is given to be 6. So this becomes 6. Lower limit is 6, upper limit is 6. When you apply the limit, integral from 6 to 6 of any function is going to be 0. 0 by 0 form. Differentiate numerator and denominator separately, as we did earlier one question. L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Applying L'Hopital's rule. Correct? So this is equal to what I get, limit x tends to 2. I am differentiating the numerator. So I will write d by dx as a differential operator. Integral from 6 to f of x 4t cube dt. Correct? Divided by, differentiate the denominator, d by dx of x minus 2. That's equal to limit x tends to 2. Now I am applying at this stage the Newton-Leibniz formula. How to apply Newton-Leibniz formula? You are differentiating a definite integral, correct? I am differentiating with respect to x. See, the variable is x now for upper limit. Lower limit is anyway a constant. Upper limit is function of x. So I am differentiating with respect to x. Remember that. Okay. So integration sign and the differential will going to cancel out. Substitute the upper limit, differentiate the upper limit. What is the variable for integral? For integration, variable is t. How do you identify that the variable for integration is t? Because there is a dt is there, no? dt means you are integrating with respect to t. dx is present means you are integrating with respect to x. If du is present, you are integrating with respect to u. All those things you must know. Because there is a dt, the variable for integration is t. So I am integrating with respect to t, where the upper limit is f of x, lower limit is 6. So substitute the upper limit. What is the variable there? T. In place of t, put the upper limit multiplied by derivative of upper limit. So hope you understand. Integration and differentiation is going to cancel out. Now 4 into, in place of t, put the upper limit f of x cube into derivative of f of x, f dash of x, minus 4 into, substitute the lower limit is 6, no? Substitute the lower, 6 cube into derivative of 6, 0. Denominator differentiate, derivative of x minus 2 is 1. Now apply limit for this, 4 into f of 2, the whole cube, correct, into f dash of 2. Here this part is 0. 4 into 6 cube into 0, 0 by 1. So again substitute the values given to us. F of 2 is given to be equal to 6. So this becomes 6 cube, correct, into f dash of 2 is given as how much? 1 by 48. F dash of 2 is 1 by 48. 6 cube is 216. I can cancel 4 1s are 4 12s are. So 216 by 12, that is 18. Answer is 18, option A. Hope I understand this. Applying L'Hopital's rule because it takes 0 by 0 form, and applying Newton-Leibniz formula for the numerator. Okay, L'Hopital's rule is applicable if it takes 0 by 0 form or infinity by infinity form. Here it takes 0 by 0 form. So I am applying L'Hopital's rule. Differentiate the numerator and denominator separately. Okay, then to differentiate the numerator, I am applying the Newton-Leibniz formula. Hope you understand this. Solution is given to you here. Detailed solution is given to you. Answer is option A. 18 is the answer. Move on to the next one. I think this is the last question. 2019 April shift, asked on 12th April, second shift 2019. Totally 13 questions were asked in altogether, combining both January shift and April shift. Okay. Many concepts are not covered in these shifts. Okay, I think sandwich theorem, the questions were not asked, and series expansion also, the questions are not asked, correct? All those questions will be covered when I do the 2020, 21, 22 upcoming years, all one by one. Many questions are there. All the concepts will be covered. If you study PYQs, it's more than sufficient actually, to some extent, I can give guarantee. First you study all the PYQs, that's most important. Many of the times the questions do repeat, okay, same type of questions will be asked. See here, limit x tends to 0, x plus 2 sin x by root of x square plus 2 sin x plus 1 minus root of sin square x minus x plus 1 equal to how much? So if you apply limit directly, I can tell it takes 0 by 0 form. If you apply limit directly or 0, sin 0, 0, correct, 0 plus 0, 0, denominator, root of 0 square, 0, sin 0, 0, 0, 0, 1, 0 plus 1 is 1. Here, sin 0 is 0. 0 minus 0, 0, 0 plus 1, 1, correct, root 1 is 1, 1 minus 1, 0, it takes 0 by 0 form, correct, takes 0 by 0 form. So we can apply L'Hopital's rule here. Better to apply L'Hopital's rule. We can rationalize also, but here L'Hopital's rule seems to be easier. So I will apply L'Hopital's rule here. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. Okay. Limit x tends to 0, differentiate the numerator, derivative of x 1, derivative of 2 sin x is 2 cos x, correct, divided by derivative of root is 1 by 2 root, 1 by 2 root of x square plus 2 sin x plus 1 into derivative of terms inside the root. I am applying chain rule. Derivative of x square 2x, derivative of 2 sin x is 2 cos x, derivative of 1 is 0. Minus derivative of root is 1 by 2 root, 1 by 2 root of sin square x minus x plus 1, correct, into derivative of terms inside the root, derivative of sin square x 2 sin x cos x, correct. I can write it as sin 2x directly, sin 2x minus derivative of x1, derivative of 1 0. Now I can apply limit at this stage. See what happens if you apply limit 1 plus 2 into cos 0, correct, divided by 2 into 0, 0 plus 2 into cos 0, correct? 2 into cos 0 is 1 by 2 into root of 0 square 0 sin 0 0 plus 1, here minus of, correct? What is there? 2 into 0 0 sin 0 0 0 minus 1 divided by, here denominator is 2 into root of sin 0 0 0 square 0 0 minus 0 plus 1, cos 0 is 1 into 2 2 2 plus 1 3, numerator is 3 there, denominator here cos 0 is 1 2 into 1 2 by, correct, 2 by root 1 is 1 into 2 2, here minus of minus plus 1 by 2 into root 1 2, correct? So this is how much? 2 by 2 is 1 plus half, 1 and half is 3 by 2, so denominator is 3 by 2, correct? 3 by 3 by 2, 3 cancels, 1 by 2, 2, answer is 2, option C. Simple question, cos 0 1 sin 0 0, and just apply the limit, you'll get the answer. Applying L'Hopital's rule, differentiate numerator and denominator separately, derivative of root x 1 by 2 root x into derivative of terms inside the root, same story here also, and apply limit, you'll get the answer. Answer is 2. Solution is given to you, option C is the answer. Detailed solution is given, L'Hopital's rule is applied, and with this we conclude this 2019 JEE Main limits topic. All the questions are covered from April shift as well as January shift. In the next video I'll be doing 2020 questions of JEE. Okay, 2020 was a COVID year also, you must remember. Exams were conducted before the COVID in the month of January, and there was a lockdown, correct? March 22nd or 23rd, I think, lockdown was there, and they conducted the JEE second phase not in the month of April because there was a heavy lockdown. You must know, you must remember that 2020 and 21. Second phase JEE exams were conducted in the month of September. So they conducted once in the month of January as usual, and the second phase was conducted in the month of September. Okay, with strict rules were followed, and they conducted the exam somehow in the month of September. And after 2020 I'll go to 21 22 like that. I'll complete the limits part of JEE PYQs and go on to the next chapter, continuity, then differentiability, then methods of differentiation, application of derivatives, and indefinite and definite integrals, then application of integrals, differential equations, like that. The calculus part will be covering first, and then move on to other part, maybe geometry part or algebra part, one by one. By this year end we'll cover all the PYQs from 2019 to 2025. Those who are preparing for January shift, it's quite useful. Okay, 2026 January shift. Also I'll be working out the many other questions from various other books like Singh or R.D. Sharma, or it may be Arihant, any other books. I'll be working out some of the important questions which can be asked for JEE exams. Our aim is not only to crack all the PYQs of JEE exams, also I'll be teaching all various competitive exams like VIT, AAA, MAHE, BIDSAT, COMEDK, KCET, NDA, and many other competitive exams, even IISCR. Okay, all those things we'll do. All mainly will target the PYQs only, because PYQs plays a vital role while practicing. Okay, so with this we'll conclude. In the next session I'll be doing in the next video I'll be doing a 2020 PYQs, okay, of limits chapter. With this we'll conclude. Thank you.